So we talked yesterday about finding these angles and the length corner to corner in a box. So we're going to look at today is this boring or drilling. So if I'm looking at the top of a piece, like I said, if the entry hole is right here and the exit hole on bottom is right there, obviously we're drilling at an angle in both directions. So we're going to look at, we created that box. The length of that box we created of course, is just the distance between center to center distance between holes. That center to center there. Should draw that a little bit better. Center to center distance between holes in that direction. The width of that box here is going to be the center to center distance between holes in that direction. So we have our length and our width. And of course, the depth or the thickness is just going to be the thickness of this, which we're looking down at it from the top. That'll be, I'm going to label it depth just because I don't want T to get in there. So to drill that, to bore that hole, we need to rotate it so that this hole is straight side to side for us. So that the hole looks like this. So what that means is that block has to rotate a certain amount. In fact, it has to rotate this angle here, which is angle R. That's our angle of rotation. And all that is doing is lining up the entry hole and the exit hole so they're side by side, so we can now tilt the table on our drill press. Well, that angle, if I were to look at it over here in this box, and I drew that box really poorly. I'm going to draw that again. There we go. This should work better. So we're looking at drilling from this corner here down to that corner here. Again, those corners at the center of the hole. That angle R of rotation is found on the bottom of this. This angle here is the same as this amount of angle we have to rotate here. Because we've got to take this line rotating over so it's here at the horizontal, side by side. Once we've done that, if we look at this from the end view now, from the side view here, front view, however you want to look at it, now the hole goes, depending on how, something like that. So now what we have to do is we have to tilt the table so that that hole is straight up and down, so the drill can just drill right down through it. So that angle is our angle of tilt. That angle right there. And that angle is the angle that we were talking about yesterday, right here. That is T. Yesterday we found the angle down here, which was T bar. Well, today we want this one up here is actually the angle that has to be tilted to get that hole perfectly vertical on our press. So if we were looking at that, these pictures really, this is going to be an example problem now. Yeah. These really challenge my artistic ability, so be patient with my drawing. So if we're looking at this, we've got our hole, our entry hole up there, our exit hole down here. And the path between them. We're not really interested in the whole block. All we are interested in is the piece that goes center to center for the hole. So we're really just interested in this portion of it. So we're going to redraw it only at that size, only that piece of it. So here's our center of our entry hole. Here's the center of our exit hole. And we're going across there. So if the thickness of this piece is 1.2 inches, and our offset side to side here is 0.8 inches, and our offset here is 1.5 inches. So we have that set up. Step one, the first thing we are going to find is the length. In your notes, I want you to take about 30 seconds and find the length for me. We'll talk about it in just a second. How would we find it? A squared plus B squared plus D squared. I don't want to call it C, but so it's the square root of 1.5 squared plus 0.8 squared plus 1.2 squared. Again, those can be in any order. We get 2.081, we're going to call that, inches. So that's the length. Now the second thing we have to find is if we draw the line corner to corner across the bottom, this is our angle of rotation. So the second thing I want to find is R. Again, in your notes, take about 30 seconds and find R, and we'll talk about that in a second. So for R, I'm looking at that triangle right here. This is R. This side here is 0.8. That's just this side is the same as this side. And this side is 1.5. So R is the inverse tangent of 0.8 over 1.5. So second tangent, 0.8 divided by 1.5. 28.07 degrees. Any questions there? So that was just this side here, which is the same as the 0.8. This side here is the 1.5. Makes that right triangle.
What's your finger with the length again?
The R for the length? R isn't really affected. Oh, the length? That is corner to corner. Let's get back here. From here to here. from here down to here, corner to corner, from the top far side to the near bottom side corner. So if you were looking at drilling that hole, that'd be the length of the center line of that hole. And then the final thing we need is we need to find T. T, remember, is our angle of tilt, and that's this angle right up here. That's T. So when finding T, I'm making a triangle again. This is the height of the box. That's the 1.2 here. That's this side over here is 1.2. This is T. The hypotenuse here is the actual bore. So that's our length from up here, 2.081. So then to find T, I have the adjacent and the hypotenuse. That's going to be an inverse cosine of 1.2 over 2.081. Which gives us 54.79 degrees. So again, what that is telling us there is if we are drilling this on a drill press, first of all, looking at the press from up the table from up above, we're going to have some sort of horizontal marker. We're going to set that block on there like this, rotated at that angle of 28.07 degrees. That's what the angle of rotation means. Next is if we look at that from the front, we're going to tilt that table so that our block is sitting on there. So now the hole we're boring goes straight up and down. This angle here is that angle of tilt of 54.79 degrees. So that we can get that precise hole on the drill press. So from now on, I'm not going to bother drawing out the whole block anymore. I might do this. Where I tell you that, come on, tell you center to center this way, it's 0.9 inches. Center to center this way is 0.7 inches. And the thickness of the material is 1.8 inches. So this means now to draw out the box that goes center to center for the holes. So our hole's going from here to here. The 0.9 is this dimension. The 0.7, that's this dimension here. And that thickness of 1.8, that's this dimension right here. And now it's a matter of going through those steps. So step one is always find the length. Finding that length, we use that three-dimensional Pythagorean theorem. Step two is always going to be to find angle R. Angle R is down here. That's our angle of rotation. And step 3 is always going to be to find angle T. So I want you guys to take about 4 minutes in your notes, try to find the length R and T, and we're going to go over them in about 3 or 4 minutes. Okay, so our length is going to be the square root of, and again, it doesn't matter what order I put these in, 0.9 squared plus 0.7 squared plus 1.8 squared. Uses 2.131 inches. How many of you had that for your length? Good. R, again, comes from this triangle here. That's R. Where this side is my 0.7, and this side's my 0.9. So R is going to be the inverse tangent of 0.7 over 0.9. Give us 37.87 degrees. And then T is going to be out of this triangle. There's T. This is going to be our height of 1.8, and this is the length of cut of 2.131. That's why we found the length first. So then T is an inverse cosine of 1.8 over 2.131. Oh, I did something wrong there. $32.36. Any questions on those? There are some generic formulas they give in the book. If I label this as L, W, and D, of course, the length is that square root of L squared plus W squared plus D squared. R is that inverse tangent of W over L. And T is that inverse cosine of D over the length. Where length, you could replace length with, of course, that formula, the square root of L squared plus W squared plus D squared, but I'm not going to get into that. Memorizing these formulas is fine if that's what you want to do, but it's better in my mind to understand where they come from, because what happens if we switch it up and now, rather than drilling top rear to lower front, what if we're drilling top front to lower rear like that? You've got to be able to switch them around and figure out what your angles are. Well, the next thing we're going to look at is, what if I don't give you those lengths? What if instead of those lengths I give you angles? It is. So here's our piece here. That's our top view. So our front view is just going to be traced down from there. Did you guys do any hand drafting or anything like that?
Not here.
where you did like front view, right end view, stuff like that? A little bit. So I mean the front view is just found by tracing the top view down. All those features that are in the top view have to be apparent in that front view. So what that tells us is the hole goes like that in the front view. And then your right end view goes off a 45-degree line. You trace this stuff over and down. Oops, I didn't do that very well. I'll do that. Trace this over and down. All these features get traced over and down. Trace these features over. And that basically maps out your end view right there. So there's your block. The hole is going from here to here. So now in this case, what we're given, instead of the dimensions here, what we're given is the angle. We might be told that this here forms a 40-degree angle, and that this here forms a 28-degree angle. We can find the other angles. We cannot find, unless we're given the thickness, we can't find the length of cut. If we're given the thickness, we can find the length of cut. If we're not given the thickness, there are formulas in the packets that tell you these things, but we can actually find it by just assuming a thickness. So I might come here and just say, hey, I'm just going to assume that this is 1 inch thick. I'm going to write assume there because it's not really 1 inch thick. I'm just saying that it's 1 inch thick so that I can do some calculations with this. Because it's all going to be proportional from there. It's similar figures. The sizes may not be the same, but the angles will be. So from that, this dimension here would be my length. This dimension here is going to be my width. So I can find the dimensions of my standard block here. Now again, they're based off of this 1 inch of depth of thickness that I'm assuming. So this is not the actual length and width of this cut, but it'll give us the same angles. So this would be L here and W here. So let's find L. Well, we have this triangle here. This is L. This is my 1 inch over here. And this is that 40-degree angle. What I have here is a tangent. Tangent of 40 degrees is equal to L over 1 inch. So I'm going to put tangent of 40 over 1 so I can cross multiply and divide here. So I have tangent of 40 times my 1 divided by 1. I get 0.839 as my length. So I'm going to come down here and label this 0.839 inches. I'm going to do the same thing here for my width. I have that triangle, looks like this. This is 1 inch, my assumed thickness. This is my width. And this is that 28-degree angle. So again, we're looking at a tangent. Tangent of 28 degrees is W over 1. Put this over 1, cross multiply and divide. So it's tangent to 28 times 1 divided by 1. So you get 0.532. So coming down here, W is 0.532 inches. From there, I can find everything else exactly the same way. I find my length. That's going to be the square root of 0.839 squared plus 0.532 squared plus 1 squared. That'll be my length. Now remember, this is not my actual length of cut. Whatever I get here, that number is the length of cut, assuming a 1-inch thickness. If the thickness is not 1 inch, it changes that cut. What it does give us, though, is a length per inch. So whatever my thickness is, I can take this number and multiply it by that thickness, and it will give me a length of cut. So in this case, it's not really a length, it's a length factor. That's why I picked 1 inch as my thickness. So now I get that factor. Whatever my thickness is, I just multiply that number by it. It gives me the length of the cut. My angle of rotation, again, that's this angle here, R, is still going to be simply the inverse tangent of W over L. So the inverse tangent of 0.532 over 0.839. That does give us the actual angle of rotation, no matter what our thickness is. And finally, T, which is, again, this angle up here. T is going to be found as the inverse cosine of that thickness, depth, we're going to call it, divided by the length of that cut. Now we're using the length factor. Whatever this number is what we're going to use in there. So that'll give us the actual angle T. So we get the actual angle of rotation and the actual angle of tilt. The only thing that we don't get is the actual length of the cut. But we calculate that length factor because we need it to find our T, or tilt. I want you to think about these. We'll go over those more tomorrow. Your actual homework for today is in the packet. Page 395 to 397. 1 through 10, finding that length, rotation, and tilt. If you want to look ahead, I don't know if it's in the packet I gave you or not. If it is, you can go ahead and look ahead. Page 401 to 404. 1 through 16 talks about is examples of how you do this with just the angles rather than the actual lengths. But the only thing you have to do is the 395, 397. So tomorrow we'll do more examples with just those angles, and then we might move on to milling.